This is the review for the quiz on sections 6.1, 5.1, 6.2, and 5.2. Number 1 was change to radian measure 7.5 degrees. Remember, to change degrees into radians, you multiply by pi over 180. Now what we do is we take the 7.5 over 180 and we reduce that fraction using math enter on our calculator. So you can tell me the answer is pi over 24 in pi radians, or you could tell me the answer is approximately 0.131 radians if you change it into decimal radians. Number 2, we want to change to degree measure 3 radians. Remember, there are 2 ways to give radian measure. One is as a numeric value, and you'll know you're in radians because you won't see that little circle that designates the degrees. Or sometimes it can be given to you in terms of pi. Well, 3 is just a numerical value. In order to change it into degrees, you multiply by 180 over pi. Use the pi button on your calculator. Don't use 3.14 as an equivalent. And then you will find out that 3 times 180 divided by pi is approximately 171.9 degrees. Find one positive and one negative coterminal angle in number 3. A is 50 degrees. So to find a positive coterminal angles were terminal rays with different angle measurements, but they lay in the same place. In order for that to happen, you take that ray and you rotate it 360 degrees, or 2 pi radians. Positive and negative coterminal angles have to do with what direction you go when you rotate your terminal angle. So if you rotate your terminal angle at 50 degrees, counterclockwise, you'll be adding 360 degrees. And you'll find out that 410 is in the same location as 50 degrees. However, if you start at 50 degrees and you go clockwise, a full circle, you'll be subtracting 360 degrees. And your new ray will be at negative 310 degrees. Well, that's pretty easy when you're working in degrees, but how about if you're working in radians? I want to find a positive and a negative coterminal angle of negative pi over 4. Well, a full circle in radians is 2 pi, so how about we add 2 pi, which is the same thing as adding 8 pi over 4. Those are called equivalent fractions. So I find out that it's 7 pi over 4. If I start at negative pi over 4, and I instead subtract 2 pi, which is the same as subtracting 8 pi over 4, I will lie at negative 9 pi over 4. Number 4, find the length of an arc that subtends a central angle of 2 radians in a circle of radius 2 miles. Arc length is the formula S equal, let's try that again, S equals R theta, where theta has to be in radians. So if you're given an angle in degrees, you have to multiply it by pi over 180 in order to get the correct answer. Well, this one's already in radians, so in order to find the arc length, all I have to do is multiply the radius of 2 miles times the central angle of 2 radians. And the units of measurement are going to be miles, so 4 miles. Number 5, an arc length, 100 meters, subtends a central angle theta in a circle of radius 50 meters. Find the measure of theta in degrees and radians. So in this case, S equals R theta. They told me the arc length is 100. And I know that the radius is 50 meters. What I don't know is theta. So in order to find theta, you divide by 50 and you find out theta is 2. Well, when you do that, we are already in radians. So in order to change this to degrees, I'm going to have to multiply 2 times 180 over pi. And I'm going to find out that 2 radians is approximately 114.6 degrees. Number 6, find the area of a sector with central angle 1 radian in a circle of radius 10 meters. The formula for the area of a sector is 1/2 r squared theta, where theta has to be in radians. So 1/2 times the radius is 10 squared times theta is already 1 radian. You're going to find out that the area is 50 and the units are meters squared. Number 7. The area of a sector of a circle with central angle of 2 radians is 16 square meters. Find the radius of the circle. Well, this time I know the area is 16. What I don't know yet, and also know the angle is 2 radians, what I don't know yet is what the radius is. So what I'm going to do is I'm going to start by multiplying these two together. The reason that I can do that is because it says 1/2 times r squared times 2. Multiplication, it doesn't matter what order you do it in. So 1/2 times 2 is 1, so you end up with 16 is equal to 1 r squared. And to find r, you take the square root. So the radius must be 4, and the units of measurement are meters. Number 8, a ceiling fan with 16-inch blades rotate at 45 RPM, which is rotations per minute. A, find the angular speed of the fan in radians per minute, and B, find the linear speed of the tips of the blades in inches per minute. So let's start with finding the angular speed. We had said the angular speed, omega, is equal to the angle, theta, in radians, divided by the time. Well, we need to first find out what theta is. So this ceiling fan, the blades rotate 45 times every 1 minute. Well, we have to find out how many angle measurements in radians those blades have rotated. So you take the number of rotations and you multiply it by a full circle. And we're going to use 2 pi since theta needs to be in radians. And that's happening every 1 minute. So 45 times 2 pi is 90 pi. 90 pi divided by 1 is 90 pi. Radians per minute. Or if you change it into a decimal, you can do that too. And again, in order to find theta, we took the rotations per minute and multiplied it by the number of radians in a full circle. For part B, find the linear speed of the tips of the blades in inches per minute. The linear speed, v, and you know from physics v is velocity, is equal to the arc length divided by the time. Well, the arc length is the radius times theta. Well, we know the radius is 16 inches because each ceiling fan blade is 16 inches long. And theta, we just found out in the previous problem, was 90 pi because it was 45 rotations per minute times 2 pi, and this occurs every 1 minute. So 16 times 90 is 1,440 pi inches per minute. Number 9. Pittsburgh, Pennsylvania and Miami, Florida lie approximately on the same meridian. Pittsburgh has a latitude of 40.5 degrees north, and Miami has a latitude of 25.5 degrees north. Find the distance between these two cities. The radius of the Earth is 3,960 miles. Well, here's the Earth, right? And the Earth's surface is curved. And even though it's not quite a circle, the Earth is really more of an oval. It's circular enough. So we would say, here's Pittsburgh, and then here's Miami. to find the distance between them, what we're really finding is the arc length. In order to find the arc length, we need to know two pieces of information. We need to know the radius, which they tell us is 3,960 miles. And we need to know theta in radians. Well, this angle here is going to be the difference between 40.5 and 25.5 degrees. That's going to be 15 degrees. But then we have to change that back into radians. Now, you don't actually have to change it into radians before you plug it in. You can just take the 15 degrees and multiply by pi over 180 to change it to radians, and then shove that all in your calculator in one full swoop. You'll find out that the distance between Pittsburgh and Miami is approximately 1,037 miles. Number 10, show that the following point lies on the unit circle, and the point is negative square root of 5 over 3, comma 2/3. Remember, the unit circle is a circle of radius 1 that's centered at the origin. We learned when we studied conics that circles had the following equation: x minus h squared plus y minus k squared is equal to r squared, where h and k represented the center of the circle. So if the center of the circle is at the origin, 0, 0, and the radius is 1, then the equation of the unit circle was x squared plus y squared equals 1. So in order to determine if this ordered pair lies on the unit circle, we're going to plug in negative square root of 5 over 3 and square it, and add to that 2 over 3 squared and find out if it equals 1. Well, negative square root of 5 over 3, when I square it, is going to be 5 over 9. Remember, when you square a negative, you get a positive, and the square root of 5 times the square root of 5 is 5. Plus 2 over 3 squared is 4 over 9. Well, they have a common denominator, so when I add them, I get 9 over 9, and 9 over 9 is 1. Number 11, find x in the following ordered pair if it lies on the unit circle in quadrant 4. So here's the ordered pair, x comma negative 2 over 7. And since I know it lies on the unit circle, I'm going to plug in x for x, and I'm going to plug in negative 2 over 7 for y into x squared plus y squared equals 1. And I'm going to solve that equation for x. But I also have to think about the fact that it's in the fourth quadrant. In the fourth quadrant, should x be positive or negative? Well, in quadrant 4, x is positive. So x squared plus 4 over 49 equals 1. And then I subtract 4 over 49, and I get x squared is equal to 45 over 49. And then I square root it, and I get the square root of 45 over 7. If you want to simplify that further, the square root of 45 simplifies into 3 square root of 5 over 7. And it's positive because it lies in the fourth quadrant. Number 12, find each reference angle. Here's the thing. For the most part, what I had taught you about reference angles was correct, except for there were these small irregularities, and these small irregularities occur in problems A and B in number 12. So I'm going to look at A and B in a little bit different fashion. And it's going to be a little bit more work, but it should help you understand what's going on. I want to find the reference angle of 5 pi over 7. And the way that I had taught it to you, you would tell me the reference angle is pi over 7, except that's not actually the reference angle. The reference angle is the number of degrees or radians between the terminal ray and the x-axis. So it may be easier to look at this in terms of degrees. So I'm going to change 5 pi over 7 into degrees. Since pi is 180, I'm just going to multiply 5 times 180, and then I'm going to divide that by 7, and I end up with something around the 128.5 0.57 degrees. Well, that's in the second quadrant. To find the reference angle, I'm going to subtract 128.57 from 180. And I'm going to get something in the range of 51.43 degrees. Well, now I want to change that answer back into radians. Now, first of all, when I wrote it on the screen, I rounded the number off. But in my calculator, I've left the full answer on the screen. So on my screen, the 128 part says 128.5714286. And then I subtracted 180 minus the previous answer, and I got 51.42857.143. So that's what's sitting on my calculator screen. To change degrees back into radians, I'm going to multiply by pi over 180. So I'm going to take the 51.42857.143, and I'm going to divide it by 180. And then I'm going to hit math enter, and I get 2 over 7. So this is really 2 pi over 7 is its reference angle. The same thing's going to happen in B, negative 7 pi over 9. The first thing that I'm going to do is I'm going to change negative 7 pi over 9 back into degrees. So negative 7 times 180, because pi is 180, divided by 9 is negative 140 degrees. That is in quadrant 3. Because negative angles, you start at your standard position and you go clockwise. Well, negative 140 is only 40 degrees from the x-axis. So the reference angle is 40 degrees. To change that back into radians, I have to multiply it by pi over 180. So I'm going to basically take 40 over 180, and I'm going to hit math enter to change it back into a to a fraction, and I get 2 over 9. So it's 2 pi over 9 is really the reference angle. So it's a little bit different way of looking at it because A and B did not fall under the same rules as some of the other radian measures I gave you. Anything that's over 6 really is pi over 6 as its reference angle. Anything over 3 is pi over 3. Anything over 4 is pi over 4. You never have to worry about those. It's these other denominators that you have to worry a little bit about. Now let's talk about C and D that are a little more straightforward. C wants to know the reference angle for negative 3. Well, remember how pi is 3.14? Well, if this radian measures at negative 3 and the x-axis is going to be at negative 3.14, then the difference between them is 0.14. For D, I want to find the reference angle for 5. Well, a full circle in decimal radians is 6.28. So we're always looking at how far our terminal ray is from the x-axis. So if it's in the positive x-axis, we want to know how far away it is from 0, or 6.28. If it's closer to the negative x-axis, then we want to know how far away it is from 3.14. So to find this reference angle, I'm going to do 6.28 minus 5, which is 1.28, and that's its reference angle. Number 14. Find the 6 trigonometric ratios of theta of the triangle. All right, so here's your triangle. Here was theta, and then this side was 3, and this side was 2, and we want to find the all 6 trig ratios for theta. In order to do that, I need to know the third missing side of the triangle. I'm just going to use the Pythagorean theorem to find the missing side. So leg 1 squared plus leg 2 squared is 2 squared is equal to the hypotenuse squared, because that's the side I don't know. So 9 plus 4 is 13. So the hypotenuse must be the square root of 13. So now I can find the 6 trig ratios. The way that I'm always going to do it is I'm going to find sine, cosine, and tangent first. So sine is 2 over the square root of 13. Cosine is 3 over the square root of 13. Tangent is 2 over 3. Because the other 3 trig ratios are just the reciprocals of these. So sine is the reciprocal of cosecant. So the cosecant must be the square root of 13 over 2. The reciprocal of cosine is secant. So the square root of 13 over 3. And the reciprocal of tangent is cotangent. So it's going to be 3 over 2. Number 15, sketch the triangle for acute angle theta and find the other 5 trig ratios. And the equation is the cotangent of theta equals 1. Now remember that the trig ratios are really fractions. So this is really the fraction 1 over 1. So what I'm going to do is I'm going to draw myself a triangle with acute angle theta. And cotangent's the reciprocal of tangent. So I already know the tangent is also 1 over 1. To what's tangent? Opposite over adjacent. So what does the hypotenuse have to be? Square root of 2. So now the other 4 trig ratios that I'm missing are the sine of theta, which is 1 over the square root of 2, and the cosine of theta is also 1 over the square root of 2. So the cosecant of theta must be the square root of 2 over 1, and the secant of theta must also be the square root of 2 over 1. Number 16, solve the triangle. Here's the triangle. This was 106, and this was pi over 5, and that was all they gave me. Now, in order to help me solve solving the triangle means finding all 3 angles and all 3 sides. So I'm going to call this A, B, C. So I have some reference point for the angles. When you do that, you call the side opposite angle A side A, the side opposite angle B side B, and the side opposite angle C is side C. And I'll make myself a little chart here, and that's what I'm going to fill out when I solve the triangle. And I'm going to start with the givens. I know angle C is 90 degrees, and since the other angle's in radians, 90 degrees in radians is pi over 2. Angle A I know is pi over 5, and I know side A is 106. So the first thing I'm going to do is I want to find out what angle B is. Well, the 3 angles in a triangle add up to 180 degrees, which is pi radians. If you ignore the pi and you do 1 pi minus 1/5 minus 1/2, you're going to find angle B. Angle B is 1 pi minus pi over 5 minus pi over 2. But you're not going to put the pi's in your calculator. You're going to ignore them. You're just going to do 1 minus 1/5 minus 1/2. And then you're going to hit math, enter, enter, and it's going to change it back into a fraction for you. And you're going to get 3 over 10. So this is 3 pi over 10. Then I have to decide if I want to find side B or side C, and I'm going to use a trig function to do that. I'll pick side C. So if I know side A and I want to find side C, the trig function that I'm going to use is sine. So the sine of pi over 5 is equal to the side opposite divided by the hypotenuse. So C is going to be 106 divided by the sine of pi over 5. In order to put this in your calculator, what mode should you be in? You should be in radian mode because you're taking the sine of a radian measure. So 106 divided by the sine of pi over 5 gives me approximately 180. So side C is about 180. It was a decimal, but I rounded it up. Last, I want to find side B. You can use a trig function to find side B, or you can use the Pythagorean theorem since it's a right triangle. So you can do a squared plus b squared is equal to c squared, and solve for b. So 180 squared minus 106 squared, and then square root that, and you find out that b is approximately 145. The remainder of this review will be on the next video.